In 1977, a machine rolled out of a small workshop in Montana that had no business existing. It was built for one simple reason: because every normal tractor on the market simply was not enough for the job waiting for it. For decades afterward, it stood as the undisputed largest farm tractor in the country, a machine most farmers only ever saw in photographs or heard about secondhand. But this is not only the story of how that giant came to be built, it is also the story of what happened years later. When a new team of engineers looked at that same legendary machine and decided, almost unbelievably, that it still was not big enough. To understand why anyone would ever want a tractor this large, you have to go back to the farmland of Central California in the middle of the 1970s. Cotton farming out there was not measured in dozens of acres. It was measured in thousands. A single operation could stretch across land so vast that a farmer driving from one end of a field to the other could burn through an entire morning just getting into position to start working. To manage ground on that scale, most large farms ran fleets of tractors, sometimes 10 or more machines working in a coordinated line, each one needing its own driver, its own fuel, its own maintenance, and its own share of breakdowns. It worked, but it was expensive, it was inefficient, and it demanded a small army of labor just to keep the operation moving during planting and harvest season. Two brothers running a massive cotton operation in California began asking a different question. Instead of running 10 smaller tractors with 10 drivers, what if there was one machine big enough to do the work of all of them combined? One engine, one operator, one machine covering the width of ground that used to take an entire crew. On paper, it sounded almost absurd, because nothing built at that time came anywhere close to the scale they were imagining. But the idea would not let go of them. And eventually, they went looking for someone crazy enough and skilled enough to actually build it. That search led them to a small manufacturing operation in Havre, Montana, a company that had already built a name for itself, constructing oversized farm equipment for customers who needed something the big manufacturers simply did not offer. This was not a large corporation with an assembly line and a research department. It was a handful of dedicated welders, mechanics, and fabricators willing to take on a challenge that had never really been attempted before, at least not at the scale being requested. When the order came in for a tractor unlike anything that had ever existed, the team did not have a blueprint to follow. They had to invent one. The first problem was power. A machine meant to pull the kind of equipment usually handled by an entire fleet of tractors needed an engine with a level of output that simply did not exist in farm machinery at the time. So the builders looked outside the world of farming altogether. They found their answer in a massive 16-cylinder Detroit diesel engine, the same type of engine more commonly found powering locomotives and heavy marine vessels, capable of producing somewhere in the neighborhood of 900 horsepower. It was an engine designed to move trains and ships, and now it was going to be dropped into the frame of a farm tractor. Everything that came after the engine had to be built around that same philosophy of borrowing from the world of heavy industry rather than agriculture. A transmission strong enough to handle that kind of torque without tearing itself apart had to be custom engineered. The frame supporting the entire machine needed steel thick enough and reinforced enough to carry a weight that would eventually climb past 90,000 pounds. Even the tires were not sourced from any tractor supplier. They came instead from massive earth-moving equipment, tires originally built to carry mining machines and construction vehicles across rough, punishing terrain, now repurposed to carry a farm tractor through cotton fields. Every stage of construction meant solving a problem nobody in agriculture had ever had to solve before. How do you steer something this heavy without the front end refusing to turn? How do you build a cab tall enough to see over an engine compartment the size of a small room, while still keeping the operator safe and the controls within reach? How do you route hydraulic lines and wiring through a structure built more like a piece of mining equipment than a piece of farm equipment? There was no manual for any of it. The team building this machine was writing the manual as they welded, bolted, and wired the whole thing together, piece by piece. The construction itself took months of steady, deliberate work, with the small crew moving between fabrication tasks that had almost nothing in common with one another. One day might be spent cutting and welding the massive steel beams that would form the main frame, beams thick enough that a normal cutting torch struggled to get through them cleanly. Another day might be spent wiring an electrical system complex enough to control an engine and transmission combination that had never before been paired with this kind of hydraulic and steering setup. There was no single supplier who could provide a parts kit for a project like this. Instead, the team sourced components from wherever they could find something strong enough for the job, adapting truck parts, industrial parts, and custom fabricated pieces into a single working machine. Every bolt pattern that did not match, every part that was almost but not quite the right size, had to be solved by hand on the shop floor, through trial and a great deal of patience. When it was finally finished, the result was staggering. The completed tractor stretched roughly 27 feet from front to back, stood well over 12 feet tall, and weighed in at close to 95,000 pounds, more than many loaded semi-trucks. Powered by that 900 horsepower engine, it carried a fuel tank large enough to hold around 1,000 gallons of diesel, letting it run for extended stretches without needing to stop and refuel in the middle of a job. Its front implement bar stretched wide enough to pull planting and tillage equipment covering more than 70 feet in a single pass, which meant that one operator, sitting in one cab, could now accomplish in a single afternoon what used to require an entire fleet of smaller tractors and an entire crew of drivers working together. Once it was finally running under its own power for the first time, even the people who built it needed a moment to take in what they had actually created. Starting that 16-cylinder engine did not sound like starting a tractor. It sounded like starting a locomotive, a deep, rolling growl that could be felt in the chest before it was even heard. Moving it for the first time meant relearning basic instincts about turning radius, stopping distance, and blind spots, because nothing about driving this machine resembled driving a normal tractor. Even simple tasks, like judging exactly where the front tires were relative to the edge of a road, required an adjustment period. Since the operator sat so far back and so far up that the usual visual cues farmers relied on simply did not apply anymore. The tractor went straight to work on the California cotton operation it had been built for, and it delivered exactly what its owners had hoped for. Instead of paying for and maintaining 10 separate machines and 10 separate drivers, they now had one operator handling ground that used to take an entire team. Fuel costs dropped, labor costs dropped, time in the field dropped. Word of the machine began to spread well beyond that one farm, first through agricultural circles, then through trade publications, and eventually into the kind of word-of-mouth reputation that turns a piece of equipment into a legend. Farmers who had never even seen the tractor in person still knew its name. It became, without any real competition, the largest and most powerful farm tractor in the country, and for many years afterward, nothing else came close. For a while, that seemed like the end of the story. A machine built out of pure necessity, assembled from parts borrowed out of the world of locomotives and mining equipment, had become the biggest thing agriculture had ever produced. And it stayed that way for decades. But machines, no matter how legendary, do not last forever in the hands of their first owners. Farms change hands, operations shift, equipment gets sold, and eventually even the most famous machines can end up parked in a field somewhere, quietly aging while the world moves on without them. That is roughly what happened here. Ownership of the tractor changed over the years, and at a certain point, the machine that had once been the pride of an entire farming operation was sitting largely unused, its legendary reputation intact, but its future uncertain. That might have been the true end of the story, if not for a family of farmers and collectors who understood exactly what this machine represented. They tracked it down, purchased it, and set about the long process of bringing it back to working condition. This was not a simple cosmetic restoration. An engine that size, sitting unused for years, needed real mechanical attention. Hydraulic systems needed to be rebuilt. The massive tires needed inspection and, in some cases, replacement. Every system on a machine that size is expensive and complicated to bring back to life. But the family committed to doing it properly, determined to preserve what had become, by that point, something closer to a piece of agricultural history than simply a used tractor. The restoration was not a quick project either, sourcing parts for a machine. This unusual meant tracking down components that had not been manufactured in decades, and in some cases, fabricating replacements from scratch using the same improvised approach the original builders had relied on. The family spent countless hours simply diagnosing what still worked and what needed to be rebuilt entirely, treating the process less like fixing a broken tractor and more like restoring a piece of machinery that belonged in a museum. Except this piece of machinery was still expected to run, to move, and to perform in front of crowds once the work was finished. Once restored, the tractor took on a second life entirely different from its first. Instead of spending its days working cotton fields in California, it became something closer to a traveling celebrity. It started appearing at farm shows and agricultural exhibitions, where crowds would gather just to stand next to it and take photographs, dwarfed by tires taller than most of the people looking at them. Video footage of the tractor running, its enormous engine idling with a deep, rolling rumble, began circulating online, introducing an entirely new generation to a machine that had been built decades before most of them were born. It had gone from a working tool built to solve a labor problem to a genuine cultural icon within the world of heavy machinery and agriculture. But being a beloved icon comes with a strange kind of pressure, especially in a world where manufacturers never stop pushing the limits of what their equipment can do. In the years following the tractor's restoration, mainstream farm equipment manufacturers kept building bigger and more powerful four-wheel drive tractors of their own. Modern articulated tractors from major manufacturers started creeping closer to the horsepower numbers the old giant had put up decades earlier. And while none of them matched its sheer physical size, the gap was no longer as enormous as it once had been. For a machine that had spent decades as the undisputed largest tractor anywhere, that kind of gradual encroachment mattered. The people who now owned and cared for the tractor were not willing to let its title slip away quietly. So they made a decision that, on its face, sounds almost as absurd as the original decision to build the tractor in the first place. If modern machinery was starting to close the gap, the answer was not to build an entirely new machine. The answer was to make the existing legend even bigger than it already was. The plan centered on the one part of the tractor that had the most dramatic potential to change its scale: the tires. The earth-moving tires it had worn since its original construction were already massive by farming standards. But there existed something even larger out in the world of heavy industry. Tires built for enormous mining haul trucks, the kind of vehicles used to move rock and ore out of open pit mines. These tires were built on a scale that made even the tractor's original tires look almost modest by comparison, standing taller than a grown adult lying down, each one weighing thousands of pounds on its own. If the team could figure out a way to mount tires like these onto the tractor, the machine would not just keep its title as the largest tractor in the country. It would grow into something even more imposing than it had ever been. Actually pulling that plan off was nowhere near as simple as bolting on a bigger set of wheels. Mining equipment and farm equipment are built to completely different engineering standards, with different bolt patterns, different hub designs, and different structural expectations. The rims that normally carried the tractor's original tires were not compatible with tires built for haul trucks, which meant an entirely new set of custom rims had to be designed and fabricated from scratch. Strong enough to handle both the weight of the new tires and the stress of actually driving on them across farmland. Every measurement had to be recalculated, because a taller tire does not just add height, it changes the entire geometry of the machine. From ground clearance to the angle of the axles, to the way weight gets distributed across the frame. Raising the tractor onto taller tires also meant raising everything connected to those tires. Steering linkages that had been engineered for the original tire height needed to be modified or replaced entirely to keep the front end capable of turning properly. Hydraulic lines running from the frame down to the axles needed to be lengthened and rerouted so they would not stretch, kink, or fail under the new geometry. The suspension and axle assemblies needed reinforcement to handle not only the added weight of the new tires themselves, but also the increased leverage created by tires that much taller sitting on the ends of the axles. Every one of these adjustments had to be planned around a machine that had originally been designed and built decades earlier, using engineering knowledge and fabrication methods that predated most of the tools available to the team doing this new work. There was also the sheer physical challenge of the job itself. Tires built for mining haul trucks are not something you casually swap out in an afternoon with a floor jack and a few wrenches. Each tire alone weighs more than most passenger vehicles. Moving them into position required specialized heavy equipment capable of lifting and precisely maneuvering objects that large without damaging the tires, the new rims, or the tractor itself. The entire process demanded a level of patience and precision that mirrored, in many ways, the original construction of the tractor decades earlier. Once again, there was no established procedure to follow. The team had to work it out step by step, solving unexpected problems as they appeared, because nobody had ever attempted to retrofit a farm tractor with tires built for a completely different category of machine. Throughout the entire process, the team had to keep circling back to a single guiding question: whether each individual change would actually make the tractor stronger and more capable, or whether it would simply make the machine look bigger while quietly making it less safe or less reliable to operate. A taller, heavier machine changes how it behaves in turns, how it settles on uneven ground, and how much force gets transferred through the frame every time it crosses a rut or a slope in a field. None of that could be guessed at. It had to be tested carefully, in stages, with constant attention to how the tractor responded before it was ever taken out for a full demonstration in front of a crowd. When the work was finally finished, the transformation was dramatic. The tractor now stood noticeably taller than it had for its entire working life. Its silhouette changed by tires so large that people standing beside it looked almost small by comparison. What had already been considered an enormous machine for nearly 4 decades had grown even larger, reclaiming and reinforcing its reputation at a moment when modern manufacturers were starting to close the gap. The engine underneath had not changed. The 900 horsepower power plant that had always defined the machine was still there, still doing the same job it had always done. But the physical presence of the tractor, the sheer scale of it sitting in a field or parked at a farm show, had reached a new level entirely. For the people who took on this project, the goal was never really about chasing a number or winning some technical competition against modern tractor manufacturers. It was about preserving something that had become far more meaningful than a simple piece of equipment. This tractor represented a particular moment in agricultural history, a time when farmers facing a real, practical problem decided that instead of accepting the limitations of what was available, they would simply build something bigger, borrowing ideas and parts from entirely different industries until they had a machine that could do what nothing else could, keeping that spirit alive, and in this case, literally making the machine grow, felt like the right way to honor what the original builders had accomplished. Today, the tractor continues to make appearances at farm shows and agricultural events around the country, drawing crowds who come specifically to see it in person, to hear that enormous engine rumble to life, and to stand next to tires that dwarf anything most visitors have ever seen, attached to a piece of farm equipment. It has been featured in documentaries, discussed endlessly across online communities dedicated to heavy machinery, and held up as an example of what happens when practical necessity collides with genuine engineering ambition. Children who visit these shows often do not fully grasp what they are looking at, only that it is the biggest tractor they have ever seen, which, in the most literal sense possible, remains true. What makes this story worth telling is not simply the size of the machine, impressive as that is. It is the fact that this tractor was pushed to its extreme not once, but twice, decades apart, for two very different reasons. The first time, it was built enormous out of pure economic necessity, a practical solution to a labor and efficiency problem on a massive cotton farm that no ordinary tractor could solve. The second time, decades later, it was made even bigger not out of necessity, but out of a determination to preserve its legacy, to make sure that a machine which had earned its legendary status would not quietly lose that status to newer, more modern equipment. Two very different generations of people looked at the exact same problem, being the biggest, and solved it the exact same way, by refusing to accept the limits everyone else had settled for. It stands today as a reminder that the biggest, most extreme engineering achievements do not always come from massive corporations with unlimited budgets and research departments. Sometimes they come from small teams of stubborn, resourceful people willing to take an idea that sounds almost impossible and simply start building. The tractor that rolled out of a small Montana workshop in 1977 was never supposed to be the largest farm tractor in the world for decades. It was just supposed to solve one farm's problem. And when a new generation of engineers decided that even that legendary machine still was not big enough, they proved that some records are not just meant to be set. They are meant to be defended, rebuilt, and made even more massive than anyone thought possible the first time around.